Today the topic for the day is Voronoi diagrams. Before we start, let me show you how a Voronoi diagram looks like. It's named after the mathematician George Voronoi. The lesson objectives for the day is to construct a Voronoi diagram and answer the questions based on it. Though we can use many digital platforms like GeoGebra and Desmos to plot them, I'll be looking for the traditional method where we have the graph sheets and we'll use a ruler and the pencils to draw exactly a three-side Voronoi diagram. So let us first learn some key terms that you have to know when you're dealing with a Voronoi diagram. B, C and S are, you have B, C, S and A. They're all called the sides. Now the area bounded by the rays and segments between the points 0.5 and negative 0.5 and 1, 1 are called, so it's about the area bounded. So this area is what you call a cell. The green segments are called, they're talking about these line segments, they are called the boundaries or the edges of each cell. And they are at the intersection of these segments. They are called the vertices. So these are the four terms that you should know: the sides, the cell, the edges, or you call the boundaries, and the vertices. Now the tools required for the day: you should have your graph sheet, your pencil, eraser, ruler, compass, and the prior knowledge required. Considering 2 points A and B being connected, and if you want to find M, which is the slope or the gradient, you must remember the formula, which is M equals y2 minus y1 over x2 minus x1. Talking about the distance between A and B, the distance of the line segment will be given by the distance formula, which is square root of x2 minus x1 the whole square plus y2 minus y1 the whole square. We have a red line here and a blue which is perpendicular to the given red line. Perpendicular means it makes a 90-degree. Now the condition for the gradient for perpendicular lines is given by, now considering M1 as the gradient for the red line and let it be 1 over 2. Then the gradient of the blue line, M2, will be, it's 1 over 2 here, it's going to be 2 over 1 with the opposite sign. This is something that you have to remember when you're dealing with the gradient of perpendicular lines. You have to flip the fraction and give the opposite sign. Next is the straight line equation to be used, considering a point on the blue line, which is x1, y1, and assuming the gradient to be m for the line in blue. Then the straight line equation is y minus y1 equals m times x minus x1. So this is when you know a coordinate on the line and when you know the gradient. You have to substitute the value for the coordinates and the gradient. You rearrange and finally you can just get the answer in the form y equals mx plus c. Let's read the first question. In a town, 3 schools A, B and C are located at the points with coordinates A 1, 3, B 6, 4 and C 6, 1. It is decided that a new school should be built as close as possible to a point which is farthest from all 3 existing schools. A. Explain why this point will be at the intersection of the perpendicular bisectors of line segments AB, BC and AC. B. Find the equations of the perpendicular bisectors of the line segments AB and BC. C. Hence find the coordinates of the point where the new school should be built. And D. Determine how far the new school will be from each of the other schools. Before I tell you how to construct a Voronoi diagram, you have to understand that there are already 3 sides A, B and C, and we are going to find a point which is at equidistant from all the 3 schools here, which is the location of the new school. Giving you a summary of the steps that will be done. Step 1. First plot the coordinates, which are the sides. In this question, we should mark the coordinates A, B, and C, which are the current 3 schools. Draw a straight line joining any 2 sides. Here we are going to use dotted or light lines. Third is draw the perpendicular bisector for the 2 sides, and we'll be using a dark line for it. Erase the dotted line that joins the 2 sides and repeat the same for all the sides to complete the Voronoi diagram. My graph sheet is ready with the axis. So I'll begin with marking the 3 sides, which is ABC. So 1 and 3, 6 and 4, 6 and 1. The sides are ready. Now draw a straight line joining any 2 sides. Use dotted lines or light lines. So I'll start with A and C first. I'll connect them with dotted lines. Can you see the dotted lines here? So this is what I have done, and I have marked the midpoint here. You have x is 1 here and x is 6. So 1 plus 6 is 7. 7 divided by 2. So this is 3.5. Now looking at the y coordinate, you have 3 here and 1. So 3 plus 1, 4. 4 divided by 2 is a 2. So this is the midpoint that is being marked here. Step 3. Draw the perpendicular bisector for the 2 sides using the dark lines. Now for these 2 sides, I have the dotted line connecting them. I have found the midpoint using the midpoint formula, or you can use a ruler to do that, or even a compass to bisect this line. Now this is the perpendicular bisector making a 90 degree with this line segment AC. You can use a ruler and a set square where you keep the ruler along this line and keep the set square exactly at this point, and you just complete the straight line. You can do this, or you can use a compass to just draw the perpendicular bisector with A and C as the endpoints and complete the construction of a perpendicular bisector. Once your bisector is completed, I'm going to erase this line. I don't need the line segment connecting the sides anymore. Repeat the same process between B and C and A and B. Let me show you the images here. I connected B and C with a dotted line. I found the midpoint, and there is the perpendicular bisector for the segment BC. Now again, I connected A and B with a dotted line, found the midpoint, and I drew the perpendicular bisector. Now when all the dotted line segments which were connecting the sides were removed, you can see the 3 perpendicular bisectors meeting at a point. I can see some extra lines here, so I'll just remove them. You have the meeting point here of all the 3 perpendicular bisectors, and they meet at a point which is the vertex, and these are the edges. The red lines are the edges or the boundaries of each cell. You can see that the school A is in this cell, school B is in the blue cell, and school C is in the green cell. So 3 cells with 3 boundaries, and this is where you have the vertex. This point, so this is the place where we'll be aiming to have the new school, which is at equal distance from all the 3. Now, the advantage of these diagrams is that if you have a student in a particular coordinate or at a distance, let's put it here, and if the child wants to decide which school to go based on distance, from a Voronoi diagram we can clearly guide him. We can clearly specify that school B is the nearest one if it is a point on the edge. So at this point it's going to be at equal distance from A and B. And remember that the shortest distance between A and B will be the perpendicular distance between these 2 sides, the line segment joining the sides and the edge. Since we have completed the construction of the Voronoi diagram, let's solve the other parts of the question. Part B. Find the equations of the perpendicular bisectors of line segments AB and BC. I'll start with BC first because you can see that this is BC and the perpendicular bisector is this line, which you can see when extended, it will connect the y-axis at 2.5. So the equation of this line is going to be y equals 2.5. So this is the equation of the perpendicular bisector for BC. Now the next part is the perpendicular bisector of the line segment AB. Now as discussed in the beginning in the prior knowledge section, you have to know the gradient m and a point on the line to find the straight line equation. From the given 2 points, let me find the gradient of this line, which is m is equal to y2 minus y1 over x2 minus x1, giving me 4 minus 3 over 6 minus 1, which is 1 by 5. So if I find the gradient for this line, if it's 1 by 5, for sure the gradient of this line, which is my perpendicular bisector for which I need to make the equation, it's going to be minus 5 over 1. Now for the coordinate, you can consider the midpoint here. This is going to be 3.5, comma 3.5. Going to the straight line equation, y minus y1 equals m times x minus x1. For this line, my coordinate for the y is 3.5 equals m is negative 5 times x minus, again, 3.5. I have y minus 3.5 is equal to minus 5x plus 17.5. I'll be shifting this negative 3.5 to the other side, so y is equal to minus 5x plus 17.5 plus 3.5. So my final answer, which is the equation for this perpendicular bisector, is equal to y equals minus 5x plus 21. Part C, hence find the coordinates of the point where the new school should be built. The new school will be built at the meeting point of all the perpendicular bisectors, which is a point here, whose coordinates are given by 3.7, 2.5. The last part of the question is part D. Determine how far the new school will be from each of the other schools. So we have already found this coordinate, and they're asking you to find the distance between this point and the other schools. So I have taken the point D and I'll apply the distance formula to find the distance between them, which is a straight substitution into the formula, and you get 2.7459. To 3SF it's going to be 2.75 kilometers. If you do the same thing with any other point, it's going to give you the same answer. So it just means that this is an equidistant point from all the 3 schools. So I think by solving this question you have an idea about how the Voronoi diagram works and what equations are to be used in completing and finding the solutions.